Hello, and welcome to Reuters Events' latest energy transition webinar. Today we'll be exploring the fuel behind the low-carbon future that the energy transition promises and asking what next for clean technology. My name is Owen. I head up the energy transition team here at Reuters Events, and I'll be your chair today. Thank you, everyone, for joining us and those listening on demand. Our mission is to unite the energy ecosystem to tackle the energy transition head-on and drive for that low-carbon, sustainable and inclusive energy future. To that regard, you very much have the facility to ask questions to our panelists today, and we hope this can be a collaborative discussion. Please do so through the question and answer box, and we'll try to get to those as many as possible, at least at the end. This episode will explore the technologies and innovations that may provide the fuel for a low carbon ecosystem. Indeed, the past 20 years of phase one renewable development through wind and solar have widely been regarded as a resounding success, with renewables now accounting for a third of global power capacity. But what next for clean technology? Joining us today to discuss and debate this, we have the pleasure of welcoming Dolf Gielen, Director of the International Renewable Energy Agency's Innovation and Technology Centre, Jonathan Carling, CEO of Tokamak Energy, and David Burns, Vice President for Clean Hydrogen at Linde. Thank you all for joining us today. Dolf, I think it would be great to come to you first. I'm sure everybody is aware with kind of the brilliant work that IRENA are producing in this space, but can you tell us a little bit more for those who are less familiar with the Innovation and Technology Centre about the work that you're doing and your role in that specifically?
Yeah, thank you very much, Owen. I think most of the audience will be aware of the significant progress of renewables in the power sector. So last year we had about 26% renewables in global power generation, and that percentage is going up by 1% or so per year. But the attention now is a bit shifting towards the end use sector, so buildings, industry, and transport, and that's where we're currently also focusing more. And there, of course, electrification and green hydrogen with renewable power can play an important role. And I think we'll hear later from David on green hydrogen. I wanted to make a few points about a report that we're going to launch coming month. It's called Reaching Zero with Renewables. And we look at the hard to decarbonize sectors, so industry and transport, and especially transport is interesting. So it's about a quarter of global CO2 emissions today. But what is less known is only half of that is for cars. The other half is for trucks, for airplanes, and for ships. And we know about electrification of cars. So this year, probably 2.5 million units sale, about 5% of the market. So that is going quite well. In fact, July global sales were about 77% above last year's. So there is growth again in that market, despite of the COVID crisis. That is very much driven by the reduction in cost of batteries. So, and that will continue. So we're there on a solid trend. But the question is a bit what to do about the other half of transport. So what to do about trucks? I mean, delivery vans probably will move like cars, but especially the long range heavy duty trucks, that is a bit of a question. And there has not been that much attention so far. There's long been a talk about, is it going to be biofuels, hydrogen, electricity? And we see now increased attention also for electricity in that market segment. But across electrification in road transport, we think more attention is needed for the integration of these renewables with the electricity system. So how do you make sure that you have really smart charging using renewables when there is sufficient renewable power available? And in aviation and shipping, so one of the solutions is to go to synthetic fuels produced from renewable power. So first you produce green hydrogen, then you use the green hydrogen to produce ammonia or methanol or another type of synthetic kerosene, for example. So that's a little bit further down the road. Economics still a bit challenging, but we think that will improve significantly in the coming years. So that's my opening remarks.
No, that's brilliant. Obviously, thanks for sharing. Just actually had a question just come in right off the back, and with regard to that report, just can you just remind us for those listening what the name of that report is, and do you have a date for publish yet?
It's called Reaching Zero with Renewables, and we intend to release that report at the end of September.
Okay, brilliant. No, that's really helpful. I think just to maybe go a little bit further into that when we talk about kind of aviation and transport specifically, what would you say are kind of the most important steps then on that road to decarbonising those industries? Are there any kind of low-hanging fruit there that are kind of the industry can go after, or is it a longer-term process that you see?
Well, there is a lot that can be done, for example, with efficiency measures, but all of that will not bring you to zero.
Sure.
So the challenge is now we're talking about solutions for zero emission aviation, for zero emission shipping. And that is still quite expensive today. There we need economies of scale. We also need to piggyback on the developments in other sectors and the technology progress to really make that happen.
Sure. Okay, that's interesting. And I think just a final point, and before we move on, and we've talked there about kind of aviation and freight a little bit, but when it comes to then wider heavy industries and kind of other materials, are you doing any work in terms of heavy manufacturing, heavy industries, steel, concrete, and any thoughts you could share with us in terms of how we can move forward in decarbonisation of those other industries?
Well, so I mean that has been discussed for decades, and the answer was always, oh, we need CCS in these sectors.
Sure.
And we still need the CO2 capture and storage in these sectors, but we think that the weight of different options has a bit changed. So hydrogen has clearly gained much more prominence as a solution in these sectors. We see also that other types of electrification, direct electrification, are becoming more prominent. We see that also, for example, biomass in combination with CCS is now being discussed, for example, as a solution for the cement sector. So it is a bit shifting, and renewables start to play a more important role in this discussion.
Sure. That's interesting, and I think that hybridization point maybe that you talked to about kind of coupling up some of those traditional kind of renewable technologies is something that perhaps we can come on to later. And I know we're going to be speaking to David shortly around hydrogen, but I think just before we jump into that one, it might be good to bring in Jonathan, so CEO, as I mentioned at the top, from Tokamak Energy. Obviously, Jonathan, thank you for joining us today. Maybe to start with, for those less familiar with Tokamak and with nuclear fusion, could you just talk to us a little bit about your organisation and the work that you're doing in the space?
Yeah, you'll be relieved to know I'm not a physicist. So let me give you just the basics of fusion. At its simplest level, fusion is what's going on in the sun. It's kind of the opposite of nuclear fission, which we're more familiar with. It's atoms fusing together. And what's really attractive about it is that it can be used to produce heat energy without the use of carbon, in an economical way, in a dispatchable way, and in a very safe way. So it offers the promise of cheap, safe, clean, dispatchable energy for the production of electricity, but also for industrial heat, because it makes energy available at very high temperature. So this does link also to things like chemical processes and the production of hydrogen, indeed, through a chemical process. So what we're doing is working a plan to bring that to commercial reality. People who know a bit about fusion know it's a science fiction thing. It's always 30 years away and so on. What we're seeing now in the private sector is a number of companies, not just us, who have got new technologies for accelerating the development and making the solutions more compact and efficient. And that's what our company does essentially.
Yeah, no, thanks. That's super interesting. I mean, you mentioned there that you're not perhaps a physicist, so I guess the natural question then is kind of what drives you then? Kind of what drove you to Tokamak? And I guess personally as and as an organisation, kind of where does that push to work in the fusion industry come from?
Well, firstly, we think that this is a very important part of the energy mix for the future, assuming that we bring it into reality in a relevant timescale. And a lot of us are motivated by the fact that humanity needs this. We know that today the energy mix is very diverse. There are many sources of energy, and we believe that will be the case in the future as well. We already see that we have solar, wind, and so on. The mix will be diverse in the future, and I think all of the technology reports that you see about energy show that there is a need for dispatchable energy of this type. And then the other thing that motivates us, if we're honest, is that working at a fast pace on very high-tech industrial and engineering stuff is great fun. We've got a great team of people, and it's a bit of a talent magnet. It's exciting stuff to work on. So that's the other thing that's motivating the team. Okay.
Yeah, that's interesting. I think the other point that you mentioned as well a moment ago was kind of that notion that fusion's something out of the science fiction. I guess the natural question there would be kind of how far away are we from commercialization and really kind of seeing fusion power as a fuel source within the energy mix?
Yeah, I think a lot of that is governed by how fast can we move. If you think about fusion in the past, it's been the province of government mega projects, which have typically taken decades to execute and consumed many billions of dollars. And a lot of progress has been made. As long ago as the 1990s, tens of megawatts of fusion power were produced in fusion reactors in a couple of places in the world.
Sure.
So the basic concept of can you make power from these types of reactions, this has been established for a long time, but very inefficiently, only by putting more energy in than you got out. So if we just carried on trying to do big experiments with big multi-government funding, it would probably take many more decades to deliver it. But technologies that have emerged that allow the devices to be more compact and more efficient and consume less capital to develop them. And there's a handful of companies around the world that have raised significant funding, hundreds of millions of dollars, and are making a serious shot of this. Most of them are targeting, demonstrating some grid-connected energy around 2030. I said I'm not a physicist, I'm an industrialist by background, and that doesn't mean that in 2030 there will suddenly be hundreds of fusion plants all around the world. We know from solar, from wind, and so on, that there is an industrial curve that has to be climbed, which in itself takes decades. But our business and others like us are targeting that sort of 2030 timeframe to demonstrate that we can produce electricity using this method.
Okay, sure. No, that's again interesting. You mentioned kind of staying ahead of that kind of industrial curve then, and kind of that 2030 goal for you. What do you say kind of moving forward is over those next 10 years, those major barriers to realizing that 2030 goal?
I think one of the key goals is to demonstrate energy gain. If you want to demonstrate a full suite of plant technologies by then you need to demonstrate energy gain a lot sooner than that. And our plan has us building our next device, our fourth compact tokamak device by 2025, with a view to demonstrating energy gain and then some multiples of energy gain. I think that's the key technology step. That's the thing that hasn't been done up until now. And we have the pieces coming together to allow that demonstration.
Sure. And just for those online, by energy gain, we're talking essentially more energy out than you're putting in to create that. Would that be fair to say? Yeah. Okay. I mean, talking then on those outputs, and we know kind of with fission, there's that kind of waste product still does come. Are there waste products with fusion, and kind of is there an impact associated with those at all?
Not really. The plants will be designed to have a similar life to a fission plant, 50 or 60 years. The only real waste comes at the end of the life of the plant. There'll be some low-level, short-lived waste just from the activation of the device itself, because there's activity within the device, but during its life, there's no waste product. Okay,
no, that's great. That's interesting. I think just the final thing then, in terms of that continued R&D phase, and obviously there's a lot going on with you guys and obviously other fusion companies. We heard Dolph as well earlier, just talking around kind of some of those factors around decarbonisation of industry. How, if at all, really, are you able to ensure that during this R&D phase and as you're developing the product, that you ensure kind of sustainability with your manufacture, with your building, with your testing? Is that something that you guys are able to take into account?
Yeah, I think one of the key ways is to make sure that we're designing plants with a long life, and that we're using technologies that don't leave behind a big legacy, and that during our development program, we're minimizing the amount of industrial footprint and energy footprint that we're using to develop the technology. So one example of that would be during our experiments, we're putting hundreds of megawatts of power into our devices to test them. But we're able to do that using relatively small amounts of energy, because we've got one of the world's biggest banks of capacitors that we can store gigajoule scale electricity and then pulse it into the machine. So the total energy consumption of the development program is relatively low.
Sure.
And by doing things like that and upgrading our machines instead of rebuilding them, we can keep our industrial footprint lower, which is good for our capital costs, but it's also good for the sustainability.
Yeah, absolutely. I think when we talk about that being kind of the end goal, then that's important and good to hear. We do have questions coming in already, but we'll kind of come to those shortly, I'm sure. I think potentially a good time to bring in David. David, thank you for joining us today.
Thank you.
Yeah, as I say, we kind of touched briefly on hydrogen right at the top, and obviously as one of the world's leading kind of gas companies, it's perhaps no surprise that Linde now are making moves into the hydrogen space. But within your capacity as Vice President of Clean Hydrogen at Linde, can you tell us a bit more about that move and kind of the work that you're now doing with regard to the hydrogen economy?
Sure. Yeah. I mean, as you probably know, as you mentioned, we've been in hydrogen for a long time now. Over 100 years, we've been in the hydrogen business, and today, over 2 billion of revenue we generate from hydrogen. So it's something we know a lot about. And more recently, with the 2016 Paris Agreement on climate change, they set some goals around global average temperature increases, keeping it below 2 degrees centigrade with a goal of 1.5. So and that required a lot of decarbonization. And it was recognized that hydrogen could play a critical role in that. The transition to a decarbonized world, if you like. More recently, we've seen post-COVID, a lot of economic stimulus funds being made available, be directed in towards clean hydrogen, particularly in Europe. And this is stimulating increased interest and demand for clean hydrogen. And so we're taking this expertise we developed over 100 years or more and applying across the value chain, whether it's production and processing, storage and distribution. That's where we've been playing for a long time, and we're kind of using that to really engage in this kind of rapidly growing area now. The demand expectations, if you look out for the next 10 or 20 years, are phenomenal. So obviously we feel we can play a role here, and it looks like it's going to develop into a very interesting industry.
Sure. Yeah, I mean, you talk there as well to kind of the need for clean hydrogen.
Yes.
Perhaps for those on the line, maybe not working directly in this space, can you just talk to us a little bit more about kind of what that means, what the colours of hydrogen, and kind of how you can ensure that hydrogen is clean?
There seems to be kind of a range of different. It's a rainbow of colours.
Yeah.
But, clean. We see clean hydrogen is kind of an umbrella for hydrogen with a lower CO2 footprint than conventional hydrogen. Conventional hydrogen we think of as the color for that would be gray, I guess.
Sure.
Hydrogen produced steam methane with steam methane reforming. That's a typical way. That's the majority of hydrogen is produced today. That can be converted to blue hydrogen by capturing CO2 and then sequestering it or utilizing it in some other way. So you're taking CO2 that's produced in the process of making gray hydrogen and sequestering it. Then the next step is green hydrogen. That's when it has a zero CO2 footprint essentially, and it's produced from fully renewable or zero CO2 power via electrolysis. And last year we took a position in ITM Power, a small electrolysis company in the UK, and we formed a joint venture, a 50-50 joint venture with them called ITM Linde Electrolysis, which now we're using to develop large-scale electrolysis applications. Really focusing on the green hydrogen segment. But under the umbrella of clean hydrogen, we're looking at really it's green and blue, and we're seeing blue as kind of a transition towards green. But eventually, certainly out in the future, it's going to be a green hydrogen economy. But for now, to get there, I think we have to go through blue. But that's the range of colours: grey, blue, green. I think there may be some others out there too, but those are the three big ones.
Yeah, no, appreciate that. Kind of running over those and
you said, how do we ensure? I guess one question was, how do we ensure it's clean? I guess, right? Or,
sure.
And so what we do there is, we have depending on which region of the world you're in, there's certain pathways that you can follow or you have to follow, or different accreditation agencies that look at verifying that the path you've chosen would give you zero, or what is the CO2 footprint in kilograms of CO2 per kilogram of hydrogen. So we kind of follow those kind of protocols, and we can, whether it's producing blue hydrogen by taking gray and removing CO2, or capturing some hydrogen from some other byproduct sources, chlor-alkali systems or ethane crackers, or if you go to green, making sure the renewable power is verified, that it really is CO2 footprint is what it says it is. We can do that to make sure that what we're providing to the market is green or some shade of blue or in between. But we can meet the CO2 footprint that the market and the customers are really looking for. Obviously, along with that comes a different cost scenario too. So,
sure. Sure. I mean, talking then to kind of that long-term green, but also in the shorter term kind of green and blue hydrogen economy that they're aiming for. You mentioned you've been obviously working with hydrogen for a long time, but there's been that pickup, especially recently, and then there's talk of potentially hydrogen following that trajectory that we've maybe seen solar go on for the last kind of 10 years. What would you say are the kind of barriers? What challenges are you facing in terms of actually kind of moving the dial there? And I guess more importantly, what are you doing at Linde to kind of move it?
Yeah, I mean, there's a lot of in this space. You hear a lot about chicken and egg, I guess, right? A lot of chicken and egg situations where you need the demand, but also you need the production, and so you need the two to go hand in hand. And as we do that, we'll start to see you'll start to get scale economics. So we'll start to see the cost of electrolysis come down. We'll start to see the cost of renewable power come down, where it becomes attractive to use clean hydrogen, where it becomes more attractive than even conventional fuels today. And if you look to 2030 and beyond, as scale grows in both production and use, we'll see the cost come down to the point when it's sort of self-sustaining. But in the meantime, government initiatives and funding is important to kind of get the business established. And we are looking to scale up, particularly on the electrolysis side. Our partner ITM is, establishing a 1 gigawatt factory in the UK that they're building. That's going to be tremendous capability, but we see that's what we'll be needing in the next few years as demand for green hydrogen grows. On the blue hydrogen side, it's pretty straightforward technology in terms of capturing CO2. That's not the hard part. It's the sequestration side. What do you do with it? How do you make sure it's sequestered or utilized? And that's where really we've seen some large demonstration projects, but not really anything that is going to, you need a lot more, I guess, to really have a blue economy take off. But in the meantime, we are focusing a lot on the green side, on the production side. Also, we have a lot of capabilities around fueling technology, where we're looking at fueling technology for large, heavy commercial vehicles, trucks, buses, trains, etc., where that is becoming economic today with current fueling. So if you're looking to decarbonize a train, convert it from diesel, the best way of doing it today is to convert it to hydrogen rather than to electrify the line or to try and put batteries on it. So there's some applications today which are economic. We'll follow those, and that'll help drive cost as we get scale. And then, as I said, it becomes kind of a self-fulfilling prophecy. Mobility is probably on the leading edge. Other areas in the industry, like steel and glass and ceramics, chemicals, refining, etc., large use, but they're kind of following, and we're seeing some applications there as well.
Okay, sure. No, that's helpful and interesting to hear. I think that the final point there is obviously noticed in the news. I think it was this week that you guys have joined now the European Green Hydrogen Alliance.
Yes, we have. Yes.
Obviously, a brilliant move. It'd be great to hear a bit more about kind of what that involves and the kind of role you'll be playing then.
Yeah, no, we're very pleased to very happy to join that. It's the European Green Hydrogen Alliance. It's a group of EU-based companies selected by the Commission to help bring I guess you call it the EU hydrogen strategy to life. This was a strategy that was rolled out a few weeks ago. And so, we believe with the extensive knowledge we've got and know-how we've got of hydrogen across the value chain, it's going to make us a valuable partner for the Commission when it comes to discussing regulations, but also incentives, and also different projects that could be developed. The Commission is still putting different work streams together, but we think it'll probably start by the end of September. We'll start to maybe have the first meetings and start moving from there. But yeah, we're very pleased to be part of that initiative.
Sure. I think it sounds interesting, and we'll be watching that one closely. I think what it brings us onto is probably something that we haven't spoken about much yet as a kind of on the panel, but is obviously a big factor with regards to all of these kind of newer technologies and in the energy transition more generally, and that's the kind of question of policy. I think perhaps to throw kind of a big question out there, if we could put together, say, a policy list, or we could put together something for you which would kind of help foster greater development of hydrogen or fusion or other technologies in aviation and freight, for instance. I guess the question would be what would be top of that list, and David, probably good to start with you.
Okay. Yeah, I mean, this is a very broad question. And I think it varies by different economies, different regions.
Sure.
And varies on the technology you're talking about, whether it's electrolysis or whether it's CCUS. Of course, I'm focusing on hydrogen here as kind of the key way of decarbonizing. But in general, we're just happy to see policies maybe more technology neutral when looking at the pathways available to reach certain goals. Then it'll allow the stakeholders involved, particularly the producers and the consumers, the customers, to make decisions on what technology will be successful in the long run. In the past, we've seen where some policies have been restricted certain technologies, such as in the past we had e-mobility focusing on batteries as opposed to hydrogen. We think policies, if it's technology neutral, will allow the industry and consumers, producers, and other stakeholders to decide what's the best going forward. And any policies that incentivize, provide some economics to allow us to build scale, I think are going to be very welcome. Obviously, clean hydrogen is more costly to produce today than conventional grey hydrogen, partly because of this scale issue. Same with renewable power. We think, as renewable power comes down, as the unit cost of electrolysis comes down, we'll start to see cost of clean hydrogen, getting to parity with conventional hydrogen. And obviously governments can help with providing incentives, both on the capex side and both on the opex side, to enable us to get to that point. I think sometimes there's something called the valley of death, I guess, in development of new technologies, where the capex and opex are still high, while you're still trying to build the scale to get the costs down. So we just need the industry needs some help to get across that void, I guess. So in simple terms, I think governments just need to develop regulatory frameworks that incentivize the production and consumption of clean hydrogen, and then it'll take off from there, I think.
Sure. Yeah, appreciate that. To admittedly a wide question. I think perhaps Jonathan, to bring you in, and it might be a more straightforward question. I'd hope, maybe looking. I know you're working in the UK, based in the UK, but working also in the Americas. What would you say, kind of, on that policy wish list? What would be up there for you?
Well, for development stage companies, when they're small, then R&D support is important. But for governments, it's more or less impossible to choose who are the serious technology bets and which ones are going to fail. If governments knew this, then there would be no problem. So we favour, for the early stage companies, the general support, like the tax credits and so on, that companies in the UK and many other countries in Europe and the US enjoy, because it supports money that's being directed to R&D and green technology without having to guess correctly. Later on in the development of these technologies, very large amounts of money get spent on big prototype projects. We're talking hundreds of millions, and whatever region they're in, governments can support at that stage, because large numbers of jobs and local economic activity is being generated, and it can be supported in that way. And then, as David said, when we get to the rollout of new energy technologies into the marketplace, there's inevitably a period when governments can provide some support to allowing that rollout to happen smoothly. But it's worth me pointing out that our company is a privately funded company, and 90% of the money that we raise to do our work comes from private industry. And I think that's the case for most of the fast-moving fusion companies. We're starting to see sovereign wealth funds, oil companies, tech funds come into the sector. They can see that things are moving and are different. So although these are ways that the government can help and are necessary, they also get quite good leverage, because capital around the world is starting to also take notice and invest serious amounts in fusion.
Sure. No, that's interesting to hear. Dolph, maybe with regards to kind of the reporting you've been doing recently and the latest publication, is that kind of policy question something that you've looked at there? And I guess anything to add on the kind of the points that Jonathan and David have just covered?
Yeah, so policy, of course, is essential, especially in these early stages of the transition. And so we think that renewable electricity has a key role to play in that. But to get to high shares of renewable electricity, you need to have sufficient flexibility in power systems. You need to have prices that reflect scarcity. You need to have the right business models. You need to have the right operational practices. So all these elements need adjustments in the market system. In Europe, we're going through that stage now. Also, we need to have the enabling infrastructure. So we need to have the grids in place. If we talk about hydrogen, we need to have the hydrogen transmission system in place, or we need to adjust the gas transmission system to allow for hydrogen introduction. And for the hard to decarbonize sectors, most of them are hard to decarbonize not because of the technology, but because they are competing on a global scale. And so you need to ensure that level playing field, or you need to ensure that they operate in a sandbox, in a niche, where they can develop these technologies. And so for that, you may need border tax adjustments. You may need specifications like we have for the CO2 of emissions of cars in Europe. So there's a lot of areas where policy needs to intervene. But the key one is to create long-term, credible goals. Where do we want to head?
Sure. Sure. That's really interesting. I think a good discussion as well around some of those policy points. I think within that, obviously, David touched on at the beginning. Obviously, it changes significantly, kind of on region, and we're at different stages in different parts of the world with regards to policy, but also more widely. And I know all three of you are kind of working internationally, in Europe and beyond. It would be good maybe to talk to then some of those differences that perhaps you notice working within Europe, within the energy transition in Europe and the development of clean technology, and then perhaps kind of comparing that to other regions. So the question being really, what would you say are those main differences in working with kind of new technologies in Europe versus working in, say, the Americas or potentially in Asia Pacific?
Well, it seems, maybe the easiest comparison is Europe, Middle East, and Africa, the EMEA region you have there,
sure.
Versus Americas. I think in the European Union, it's made a commitment to be, have a carbon neutral continent by 2050, and so this is putting a lot of pressure on a lot of different regulations. Every country has to have its own national strategy now to achieve that. And so it can be somewhat fragmented at the country level, but still at the EU level, it kind of comes together, and there's a commitment to get there, to get there by 2050 to be carbon neutral. In the US, it's not at the federal level, maybe it's the state level, and you have California kind of leading through its low carbon fuel standard program in particular. That seems to be driving a lot of behavior, and it seems very successful. And then in Asia, it's more kind of country by country. Obviously, you have China doing what it does, and mandating a certain level of zero emission vehicles on the road, etc. And then Korea is also a big player in Asia as well in terms of its goals around decarbonization. But a lot of differences. You've got the EU playing a central role here in Europe, driving country behavior. The US is kind of more laissez-faire, with California doing what it got its own program, and some of the Western states picking up from that. And then Asia more kind of specific, country by country. So it's more of a general kind of view of what we see.
Yeah, no, that's interesting. Dolph, did you want to jump in on that point?
I mean, it's energy policy and it's climate policy, but there's also a very important industry policy component to this. So
Sure.
a number of countries, I mean, if you, for example, look at China, I mean, there is clearly a big driver is where are the industries of the future? And if you look at the stock price of Tesla, or you look at the stock price of the hydrogen companies, then it's quite remarkable what the expectations are to all these sectors. So there seems to be a general feeling that we're really going for a very fast transition in the coming years.
Mm-hmm.
No, that's interesting. I think perhaps a final question then when we look at achieving that transition, and again to put you guys on the spot before we move on to some audience Q&A. David and Jonathan, you can't say fusion and hydrogen, but in terms of kind of that key enabler, perhaps too simplistic to look at one technology, but what would you say is that kind of the key next step that really needs to happen to kind of drive this forward? Is it those policy things we've been talking about? Is it a specific technology? Where would you say?
I think it's more kind of policies that stimulate demand, and then we can follow with production and drive the cost down to the point where it's self-sustaining. So I think it's I won't use the word hydrogen, but I think that's going to be key. But
Sure.
I think policies that stimulate on the demand side, I think, and enable the transition on the demand side without putting undue burden on those who are transitioning, or taking the first step in transitioning to a lower carbon kind of future. They need to be rewarded for doing that, and or incentivized to do that, should I say? And then I think that will enable the whole kind of value chain to follow on behind.
Okay. No, interesting. Jonathan, I saw. Sorry, did you want to jump in on that one as well?
Yeah, the only reason I wanted to jump in first is because I gave this quite a lot of thought, and I think it is hydrogen is the non-fusion enabler that's very important. I spent most of my career in the automotive and aviation industries, so I've burnt a lot of stuff in my time. And if you look at the hard to fix areas, like some of the industrial processes, some of the big scale transportation challenges, hydrogen is a big enabler. And I'm not saying that to diss fusion, because we know that that's one of fusion's hands, right? But it's a big challenge. There's, I mean, David can describe it better, but there's infrastructure, and there's all of the use methods. But when you step back and look at it, it's got to be a key part of the future energy mix for the world, I think.
Okay, interesting. I know there's an audience question actually came in specifically around zero carbon aviation, which Jonathan, you suggested you think is possible today. Perhaps the same question for Dolph and for everybody listening. Do you think that kind of zero carbon aviation is something that is achievable at the moment, and if so, how, and if not, then when?
So there is a lot you can do with biofuels, for example. Of course, you can have a discussion, are all biofuels zero carbon fuels? But we think that there is, if you do it the right way, there is a significant potential for sustainable biofuels, but probably that is not enough. And the other half, that's then where synfuels come into play. Synfuels produced probably from hydrogen. So electric, I mean, there was a question about electric airplanes. So technically today you can do it if you don't fly too far. But for intercontinental flights, it's still very far out. We would really need a breakthrough in storage technologies. And so that's a little bit more speculative. Hydrogen itself, as an aviation fuel, also has a bit of a storage disadvantage. So that's why there's so much attention for these syn fuels.
I think was there a study published by the Commission about aviation a few months ago, I think, right, where they talked about starting small with regional aircraft and kind of building up, but it requires modification to aircraft as well. It's not a simple case of just changing out the fuel, right? It was quite significant. But they also talked about how maybe you can decarbonize the airport, the infrastructure first. I mean, that's one step you could do. You know, all the vehicles used at an airport would be one step, a simple step.
Yeah, no, that's interesting, and I think that kind of electrification question throws up a point, and I know somebody kind of touched on Tesla earlier. There's a question come in asking specifically kind of around what would happen to a company like Tesla if hydrogen were to dominate. But I think really the question more should be, are we looking at a technology dominating? Are we going to see something like hydrogen dominate in the way that perhaps oil and gas has, or are we really looking at that threat not being there for Tesla or a common company, because the future of an energy system does look more mixed?
I guess we see maybe a bifurcation where battery seems to be for personal automobiles, for the distances involved and kind of this scale. Batteries have a great fit, but for heavier commercial vehicles, trains, buses, trucks, given the you don't want to put the batteries can take away payload if you're looking for range. Also, another Achilles heel is the charging time versus being able to charge with hydrogen. So we think for commercial sector, we see hydrogen as a great fit and kind of moving forward. And I think batteries may be a better fit in the small automobile section, end of the market. So I don't think it's either or. I think maybe there's a fit for each. It's just one is going to take the smaller vehicle part of the market, and hydrogen will take the larger commercial vehicle. And that's what we see anyway.
Interesting. Would anybody disagree or agree potentially?
The only one I'd semi-disagree on is the trains, because I think the trend for electrification of trains without batteries, just with pantograph direct feed is pretty strong. So I can't see that being a big. There could be some hydrogen niche in certain regions, but mostly it's going to drive towards electricity.
I guess we were thinking more kind of maybe small, maybe suburban lines where you're using diesel vehicles right now, diesel trains, so you convert to hydrogen as opposed to putting electric cable lines in it. So it's not the heavily used main lines. So.
And in the end, they're not that different. I mean, a hydrogen fuel cell truck is still an electric truck.
Yes. It's just you don't have how many kilograms of batteries on there, right? That's the difference. It's still it's a fuel cell electric vehicle. So
sure. I think we're kind of coming towards the end. I think it would be perhaps improper to kind of talk through a technology webinar and not address that other big kind of buzz technology that's out there at the moment, obviously being kind of carbon capture and CCUS. There's a couple of questions that just came in, just asking for people's kind of thoughts on that more generally. So maybe just to kind of throw that technology out there, and then does anybody kind of have comments on the kind of progress of that and the potential for CCUS in the kind of future energy mix?
Yeah, I mean, I'm thinking of it, CCUS during the production of hydrogen, where it's pretty straightforward, capturing CO2 off a hydrogen production process. You can do it out of the syngas, the raw syngas, where you can maybe get 50 or 60% of the CO2, or you can capture it out of the flue gas, where you can get 90% or so. So that's pretty straightforward. As I said earlier, it's really what you do with it. It's a sequestration piece where does it go? And in a way, if you're going to do a blue hydrogen kind of strategy, you also need a CO2 strategy that comes with it. You need a network of pipelines to collect CO2 as well. And then obviously you can take CO2 into sequestration downhole, but maybe there's a role for carbon or CO2 being used to make synthetic fuels with hydrogen as well, methanol and things like that. And I know there's some technologies out there for like direct air capture, which I think are in their infancy, but there's several pilots going on right now, just capturing CO2 out of the air, and at low concentration and low pressure, it's difficult to do, but it'd be interesting to see where that goes. But in terms of on the standard, hydrogen production technologies, CCUS, the CC part is straightforward. It's the UNES part where the difficulty is.
Maybe I can add to that. I mean, we also have CCS in our scenarios. We think in certain sectors it will be needed. We also see prospects for blue hydrogen, but in the power sector, the discourse has radically changed over the last 20 years. So we are very skeptical on the prospects of, for example, clean coal, so coal-based power generation with CCS. We think that the economic case in comparison to the low-cost renewables we see now will be very challenging. I mean, I saw today a number, the latest PV auction in Portugal was 1.3 US cents per kilowatt hour. So it's amazing.
Okay.
Yeah, I'm also a little bit skeptical about this, and we see it as more of an interim technology, the carbon capture, because of the progress of the other technologies, including the renewables, and also the applicability varies hugely regionally, depending on whether you think you have a nice hole in the ground to use for this or not. So we see it as an interim solution, and likely to be surpassed by the progress of other technologies, be it fusion, renewables, and so on.
Yeah, I mean, I guess in some ways we see it as a way of getting hydrogen to the market very quickly at scale, use it as a stepping stone to green hydrogen in the future. But, there's a lot of grey hydrogen infrastructure out there. If you can convert it to blue, it gives you a lot of hydrogen that you can then develop the demand side, and then come on later with electrolysis, etc., to fill the gap with the green hydrogen.
Sure.
Yeah.
Great. I think I guess a final point, and just take something there, Jonathan, when you kind of mentioned about potentially kind of optimism and pessimism. A final question again, one final time to put you guys on the spot. And we've talked a lot today and got enthusiastic about kind of the technologies and the kind of progress that has been made. When we look, and again, let's maybe just look at Europe, as there is that concrete target now for 2050 and net zero. I think this discussion around technology shows that it can be possible. But I think the question more is do you think it will be achieved? I guess pessimistic or optimistic for the next kind of 30 years.
No
one wants to.
I think we have no other answer. Well, obviously, I believe it will be. Yes.
Have to be optimist.
Yeah.
I think it won't be achieved, but a huge amount of progress will be made.
Sure.
If I was putting my own money down, I'd be in a sort of close but no cigar type of bet. Okay. I think there's a lot being done, but it's not actually that long to get to zero. And there's the key thing is not to wonder; it's to try everything we can to get there. We won't get there sooner by worrying about it. We have to pursue. There's none of us is right about our technology. We all have to push hard. And if it all goes well, we can get there. We've seen people's roadmaps and paths and so on. Yeah. I certainly believe we can get close.
I guess if at least we try, and if we miss by a little bit, we're still better off than never having tried in the first place.
Exactly.
Right? Yeah.
Not like we have a huge choice, right?
Yeah. Absolutely. I think that will bring us to the end. I know we're getting close for time now. David, Dolphin, and Jonathan, a massive thank you for taking the time. Jonathan, we'll see you in the Energy Transition North America later this year, and Dolphin and David will be seeing you in Energy Transition Europe. So looking forward to that for everybody tuning in as well. Do be sure to join us at the summits and hear more from our speakers today. As I mentioned, everything will be available on demand. So those will all be sent out to registrants. And if you're listening now on demand, then I hope you enjoyed the session as well. Once again, David, Dolph, and Jonathan, a massive thank you for today. And we look forward to seeing you in November.
Thanks very much.
Thank you.
Cheers.
Bye.